Okay, ma? So we have studied various velocities in the last class. Now we are trying to derive these laws using this pressure equation. We have derived the equation of pressure, how much pressure is exerted by gas molecules on volume of a container or on the sides of a container. Clear, no? What is meant by P here? Pressure. M? Mass of what? Mass of single molecule. Okay, ma? M is called, that's what we have derived, no? M is called mass of single molecule of a gas. Okay? N is how many molecules are present, number of molecules. VRMS, RMS velocity of the gas molecules. Capital V, total volume of the gas container. Okay? Now by using these laws, we are trying to derive, by using this equation of pressure, we will derive the equations of what you call this gas laws. First one is Boyle's law. So what is Boyle's law? Boyle's law says that pressure of a gas is inversely proportional to volume. This is called as Boyle's law. So for this condition to be satisfied, what are the constants which should be present? So here M should be constant, no? What is M? Mass of a gas, or you can write N into M. What is N into M? Total mass of the gas. N into M, total mass only, no? M is the mass of single molecule. Are you able to understand, ma? N into M is the mass of total mass of the gas. So total mass should be constant, or you can write here Nm is called what? Total mass of the gas. So same discussion we have studied in chemistry also, no, ma? Once again we are discussing here. Okay. Next, Sima here, one point is that VRMS, already we have written some equations. No, RMS velocity of the gas is equals to square root of 3RT divided by capital M. Do you remember this one? Do you remember this one, ma? RMS velocity is equals to square root of 3RT divided by capital M. M is mass of 1 mole of a gas. It is a constant. R, universal gas constant, it is also constant. So therefore what I can write? I can write VRMS is directly proportional to root T. This is what I can write now. Clear, no? Because capital M, mass of 1 mole of a gas, it is already a constant. Capital R, it is also a constant. So therefore RMS velocity is directly proportional to root T, but here in the equation what I have RMS square, no? So therefore if I square on both sides, RMS whole square is proportional to T. This is what I can write now, ma? Are you able to understand? So therefore in this equation, if RMS velocity should be a constant, then temperature of the gas also should be constant. Are you able to understand? So if pressure is inversely proportional to volume, M into N should be constant. RMS velocity square also should be constant. But RMS velocity depends on what? Depends on temperature. So if RMS velocity is constant, temperature also is a constant. Are you able to understand, ma? So therefore, as VRMS is a constant, we say temperature is also a constant. Are you able to understand? So therefore, what are the conditions in which we can define this Boyle's law? Condition is mass should be constant, temperature also should be constant. Then I can say pressure is inversely proportional to volume. This is called as Boyle's law. Are you able to understand? So cases at which you are deriving this Boyle's law, this you should not forget. Pressure is inversely proportional to volume only if these two, if they are variable. Number of moles of a gas should be constant. Number of moles of a gas is constant means total mass of the gas also is a constant. Temperature also should be constant. Why you are saying temperature is constant? There is no equation of temperature no here. Equation lo temperature unda meeku ledu. But still we are saying it is a constant. How? Because RMS velocity is directly proportional to root of temperature. So if RMS velocity is a constant, temperature also is a constant. Understood, Nama? Therefore we say pressure, as pressure is inversely proportional to volume, can I say PV is a constant? Product of pressure into volume is a constant. So therefore in two different cases I can write P1 V1 is equals to P2 V2, or you can write P3 V3. So it goes on like this. So whatever it may be, totally it should be a constant. Are you able to understand, ma? So then let us try to have one more derivation by using this relation, ma, P1 V1. Now see, we know that density is equals to mass by volume, no? Density is equals to mass by volume. So therefore, instead of volume, what I can write? I can write mass by density, no? Instead of volume, I can write mass by density. So take this equation, substitute here. Then I will get one more equation. So P1 multiplied by, or just I will substitute in of this equation, I better substitute in this equation. Okay, ma? So pressure multiplied by mass by density, it is a constant. Are you able to understand? So pressure multiplied by mass by density is a constant. Mass is already a constant, no? Mass is already a constant. So therefore, what I can write? As mass is already a constant. Clear, Nama? What I can write? I can write P by rho is a constant. Or you can say pressure is directly proportional to rho. Rho means what? Density of the gas. Understood, Nama? So these are the information which I will get by using Boyle's law. Okay? So therefore I can write P into V is a constant. P by rho is also a constant. But mass should be constant. Temperature also should be constant. These are the equations of Boyle's law. Understood, Nama? Make a note. Now if I draw the graph between pressure and volume, can you say how the graph will look like? Okay, ma? If I draw the graph between pressure and volume, what should be the shape of the graph? So this should be the graph of, they are inversely proportional. It means if one value increases, other value should decrease. Then only the product will be a constant. So graph must be like this. So this is pressure and this is volume. Understood, no? See, because if one value increases, other value decreases. Clear, no? If volume is increasing, pressure should decrease. Is it clear? But what temperature? Temperature should be constant. Understood, no? And if you want to draw the graphs at different temperatures, let us see that case also. Completed, no, ma? This side. Now see. See, ma. So for example, already in chemistry also we have discussed this one, no, one more time just we are discussing. For example, this is one graph, another graph, third graph. This is a temperature T1, temperature T2 or temperature T3. Now what is the relation between T1, T2 and T3? Are they equal? Which one is greater than which one, or which one is less than which one? So definitely T3 should be greater than T2 should be greater than T1. Understood, no, ma? Because already we have studied, no? For example, if you take at any volume, you take this volume. You take this volume V dash. At same volume, we have different pressures. Okay, ma? And where we are having highest pressure, so this is pressure P1, this is pressure P2, and this is pressure P3. Clear, no? So definitely here pressure is greater. So as temperature increases at constant volume, what happens to pressure? Pressure also increases. Are you able to understand? If temperature of gas increases, what happens to the gas molecules? Their velocity will increase, no? If temperature of gas molecules increases, velocity of gas molecules also increases. If velocity increases, they hit the container with greater force. Container ni ekku force to hit chestayi kada. Once they hit the container with greater force, it means they are exerting more pressure. So pressure automatically increases. So higher the temperature, greater should be the pressure at constant volume. Clear, no? So definitely T3 is greater than T2 is greater than T1. This is how I can write. Okay. Similarly, if I draw one more graph, for example, this is PV graph. Now on y-axis, on x-axis, I am taking pressure. Then can you say how the graph should look like? Graph should be parallel to x-axis. What can be the reason? PV is already constant, no? So whatever may be the change in pressure or what change in volume, product of PV will never change because it is a constant. Clear, no? Similarly, if I draw one more graph, okay, ma? This is PV and this is volume. Now what about this graph? Here also the shape of the graph does not change. It is parallel to x-axis. Again, same reason. Whatever may be the change in volume or change in pressure, product of PV doesn't change. Understood, no? Similarly, if I draw one more graph, okay, ma? So I will draw pressure versus density graph, no? Pressure versus density graph. So graph should be like this. Why? Because pressure and density, they are directly proportional, no? So as pressure increases, what happens to density? Density also should increase. So that should be the shape of the graph. Okay. Similarly, if I draw one more graph. So how can I draw the graph? So this is P by rho, and pressure is increasing continuously. Then so P by rho graph I am taking with respect to pressure. Then shape of the graph should be like this, no? Parallel to x-axis. Why? Because P by rho is a constant. Clear? Similarly, you can draw one more graph. So this is P by rho, and here I have volume. Here I have density. Then again the graph should be parallel to x-axis. Because whatever may be the change in pressure and density, P by rho always remains a constant. If pressure increases, density also increases. Understood, Nama? If pressure decreases, density also decreases. So that this ratio always remains a constant. That's what we can say, no? If pressure increases, density also increases because they are directly proportional. But their ratio always remains a constant. This is a very, very important point. Clear? In studying the velocity of waves, in waves topic also, we will study this topic. What is the effect of pressure on velocity of a gas? What is the effect of density on velocity of a gas? There is no effect. Okay, ma? If pressure increases, velocity of gas doesn't increase. Because P by rho always remains constant. That we will study in waves topic. Understood, no? Make a note. So 1 by 3 to multiply చేస్తుంటే 3 డినామినేటర్లో ఉన్నట్లే. అదే పైన రాసినారా? పైన రాసిన 3 కింద ఉన్నట్లు మర్డర్ చేస్తాను. ఎప్పుడు రాసిన డినామినేటర్లో అక్కడ నేను న్యూమరేటర్లోనే ఉంది. ఓకేమా? సో దిస్ ఈస్ ద ఈక్వేషన్ ఆఫ్ ప్రెషర్. నౌ లెట్ us try to understand how we can understand this Charles law based on this pressure equation. ఓకేమా? సో వాట్ ఈస్ చార్ల్స్ లా బేసికలీ? చెప్పండి. Volume is directly proportional to temperature. This is called as Charles law. Okay. So volume will be directly proportional to temperature. Here there is volume, but where is temperature here? So I can write Vrms is directly proportional to root T, no? So therefore Vrms square is directly proportional to temperature. So therefore how can I write this relation? I can write product of PV is directly proportional to Mn, okay, ma? And it also proportional to T. I can write like this, no? Instead of Vrms square, I can write T, no, ma? Temperature. So therefore this is the method of equation I have written. So what is Charles law? Charles law basically is volume is directly proportional to temperature of a gas. So what are the terms which should be constant? Okay, ma? Pressure should be constant, no? Clear? And what about mass of a gas? Mass of a gas should be constant. And what about temperature? Temperature should be a variable. Understood, no? So therefore what are the terms which are a constant, ma? Pressure is a constant. Similarly, total mass of the gas also should be constant. In this condition I can write pressure is directly proportional to temperature. This is what I can write. Volume of a gas is directly proportional to temperature. Understood, no, ma? So therefore if I want to write this one in the form of an equation, then I can write V by T should be constant, no? If T comes to the other side, it becomes divided. So V by T should be constant. Clear? So in different cases I can write V1 by T1 is equals to V2 by T2 is equals to V3 by T3, and it goes on like this. So I can write like this. Clear, no? Understood, no? Similarly we also have density is equals to mass by volume. So therefore volume is equals to mass by density. Okay, let us try to substitute here. So therefore instead of volume I can write m by rho into T should be a constant. Clear, no? What is m here? Total mass of the gas. Mass of the gas is already constant, no? Therefore rho into T also should be constant. Clear? So I can write rho 1 T1 is equals to rho 2 T2, and it goes on like this. Are you able to understand? So they should be constant. Now if I go for graphs, clear, no? How can I draw the graphs? First of all, I will draw the graph between volume and temperature. Can you say what should be the shape of the graph, ma? Volume is directly proportional to temperature, no? This should be the shape of the graph. If temperature increases, volume of the gas also increases, but which one should be constant? Pressure should be constant. Understood, no? So, pressure of the gas should be constant. This is the shape of the graph. Are you able to understand? Now, if I draw similarly two different graphs, for example, clear, ma? So, this is volume and this is temperature. If I draw graphs like this, okay? So, this one is at a pressure of P1, this one is drawn at a pressure of P2. Now, what is the relation between P1 and P2? What is the relation between P1 and P2? Okay? Problem, Sima. So, if this is the graph, for example, let us take at same temperature, if temperature is a constant, okay? If temperature is a constant, I have two different volumes, no? So, here it is volume V1 and here it is volume V2, okay? If temperature is a constant, then what I can say, if pressure is lesser, it means volume should be greater. Are you able to understand, Amma? So, if volume is lesser, it means pressure should be greater, because pressure and volume, they are inversely proportional, no? So, we know that pressure is inversely proportional to volume at constant temperature. Clear, no? So, if volume is lesser, so definitely I can say V1 is less than V2, no, ma? So, therefore, I can say P1 should be greater than P2. So, that is how we can analyze the graphs. Understood, no? Clear, no? Similarly, any other graphs? V by T versus V or T graph also we can draw. Clear, no, ma? Some more graphs how we can draw is, so on y-axis we will take V by T versus T. Then what should be the shape of the graph? Graph should be parallel to x-axis. That's all, no, ma? Because already we have written V by T ratio, it remains a constant, whatever may be the change in temperature or volume. Similarly, one more graph, how can I draw? I can draw a graph between, again, V by T with respect to volume. Now, what should be the shape of the graph, ma? So, again, the shape of the graph should be like this, parallel to x-axis. Clear, no? One more graph, I can write pressure temperature graph. Now, what about this one? PT graph. No, sorry, not a pressure, ma? Density versus temperature graph. Okay. So here what I got density into temperature is a constant. This is the value which I got, no, ma? So therefore density is inversely proportional to temperature. So what should be the shape of the graph? If one value increases, other value should decrease, no? So the shape of the graph should be like this. Okay. Or if you want to draw some more graphs, you can draw. How can you draw? For example, if I want to draw PT graph, rho T graph, density into temperature graph. With respect to temperature, similarly, rho into T graph with respect to density. What should be the shape of the graph? They should be parallel to x-axis. Clear, Nama? Why they should be parallel to x-axis? Because rho into T is a constant, no? So with respect to temperature or with respect to density, they always remain constant. So that is about the law which is called as Charles' law. See, all these laws we are trying to derive from only one equation. What is that equation? Pressure exerted by gas on walls of the container. Clear? Previously in chemistry, we have derived the same equations by using ideal gas equation. Now we are deriving by with respect to pressure. Clear? Okay. So next law is Gay-Lussac's law. And what is it is also called as Charles' law of pressure also, ma'am. Clear? Another name for Gay-Lussac's law. So I can say pressure is directly proportional to temperature. So if pressure is directly proportional to temperature, what are the terms which are constant, ma? Volume should be constant. Clear? And similarly, mass of the gas also should be constant. So these are the terms which should be constant. Clear? Because already we know that Vrms square is directly proportional to temperature. If Vrms is constant, it means temperature also is a constant. Clear, no? So therefore, what are the terms which are constant? Mass of the gas is a constant. Volume of the gas also is a constant. It means we are heating the gas or we are cooling the gas at same volume and a fixed container. If container is fixed, it means volume is also fixed. That is called as a fixed container. Clear, Nama? Therefore, now let us see what we can write. I can write P by T is a constant. Clear, Nama? So, if P by T is a constant in different situations, I can write P1 by T1 is equals to P2 by T2, and it goes on like this. Understood, no? So, therefore, if I draw the graph between a pressure and temperature, what should be the graph? Okay, ma? What should be the graph? Pressure is directly proportional to temperature, Nama, so it is the graph which passes through the origin, and if temperature increases, pressure also increases. Okay, but the condition is volume should be constant. Clear? Similarly, if I draw the graph like this, okay, ma? So this is pressure and this is temperature. I am taking two different graphs. Okay, so first of all, here there is pressure volume V1, and here it is volume V2. Now, what is the relation between V1 and V2? V1 greater than V2 or V2 greater than V1? So, Sima, here if I take at same temperature, I have different pressures, no? Here I have pressure P1, here I have pressure P2. If temperature is a constant, if pressure is lesser, volume should be bigger, no? So, P1 is less than P2, so definitely I can say V1 should be greater than V2. That is the graph. Understood, no? Similarly, some more graphs, how can I draw? I can take a P by T graph, no ma? Okay. So this is P by T graph with respect to pressure, or one more graph I can say, this is P by T graph with respect to temperature. Now what about these two graphs? There should be straight line. Because P by T is always a constant, no? So graph also will not change. So this is the shape of the graph. Understood, no ma? That's it. So this law is called as Gay-Lussac's law. Okay? Okay, ma? So next law which we are discussing is Avogadro's law. What is Avogadro's law? Sima. If I take three equal volumes of any gas, okay? So Bucca sisters, okay, ma? So three equal volumes of gas. Volumes are same. For example, let us consider this is 1 liter, 1 liter, 1 liter gas. Clear, no? And whatever may be the type of gas which you have, whether it is a diatomic gas, a triatomic gas, whether it is an ideal gas which is monoatomic, whatever may be the type of gas. For example, I am taking hydrogen gas, I am taking oxygen gas or helium gas, HCl gas, anything you can take. Clear? So volumes should be constant. Pressures also should be constant. Temperatures also should be constant. Then any sample of any gas always contain same number of molecules. If 1000 molecules are present in this gas, same 1000 in this oxygen also, same 1000 molecules in helium gas also. Are you able to understand, ma? So this is called as Avogadro's law. Clear? And this one again we can prove with the help of this pressure equation only. Okay, ma? So we know that pressure is equals to 1 by 3 mn V RMS square divided by V. This is the relation which we have, no? Clear, no? Therefore, I can write pressure into volume is directly proportional to 1 by 3 mn V RMS square. Clear, no? I can write like this. Okay? Is equal to symbol also I can use here. Okay? Now, Seema. So, in this condition, what is Mn? Mn is nothing but mass of the gas, no? And what is VRMS square? Velocity of gas. Clear? So, here I can write one condition, ma. If temperature is a constant, okay, ma? If temperature is a constant, then kinetic energy of any gas will be constant. Clear? Are you able to understand, ma? For example, if I am taking two gases or three gases and we are maintaining them at same temperature, who decides velocity of a gas, ma? Who decides velocity of a gas molecule? Temperature decides and its heat energy decides. So temperature decides the kinetic energy of a gas molecule. If all these gases, if they are maintained at same temperature, then their kinetic energies also should be equal. And what is the formula for kinetic energy? Half m1 v1 square is equals to half m2 v2 square is equals to half m3 v3 square. This is called as kinetic energy. No? What is m1? m1 is the mass of molecule in first container. Clear now? m2 is the mass of the gas in mass of single molecule in second gas. And m3 is mass of single molecule of a gas in third container. Okay? So masses may be different. Velocities also may be different, but kinetic energies, they will remain constant. Okay? Because kinetic energy is a form of energy, it depends on total energy of the gas molecule, and total energy depends on temperature. Are you able to understand what is happening? Clear, So therefore, if temperature is a constant, then kinetic energy of gas molecules is also constant. It means in first container, second container, and third container, in every container, these molecules, they have same kinetic energy. Every molecule has same kinetic energy, whether it is a hydrogen molecule, oxygen molecule, or helium atom. Are you able to understand? Masses may be different. Definitely, mass of helium is, hydrogen is how much? 2 atomic mass units. Clear number? Mass of oxygen is 1616, 32 atomic mass units. Helium is 4 atomic mass units. Masses are different. So velocities also will be different. But total kinetic energy, that is a constant. Because temperature is a constant. Are you able to understand what is happening? So make a note of that point. Clear number? So therefore, completed up to here? Okay. So therefore, what we write? Therefore, we write, okay, masses of individual molecules or atoms may be different. So, individual velocities of gas molecules may be different. But what about kinetic energy? But kinetic energy of each molecule in every gas remains the same. Understood now what is happening? Okay, now see. So therefore, if kinetic energy is same, listen very carefully how we are deriving this one. So I can cancel half and half, no? So mv square, they are constant. Clear, no? So therefore, what I can say, clear, no? Here I can say 1/3 mn Vrms square, it is a constant. Clear, no? So if it is a constant, then what is Mn? Mn is the total mass of the gas, no? And what is Vrms square? Velocity. Now see. So therefore, see my same equation I can write like this also, no? 1/3 m1 n1 v rms 1 square is equals to 1/3 m1 n1 v rms 2 square. This is equals to 1/3 m2 n2 v rms 3 square. Okay, there should be what? There should be constant. Are you able to understand, ma? I can write like this, no? Now, instead of this total equation, instead of 1/3, if I write 1/2, will anything change? If I cancel all this 1/3, then you can cancel 1/3. Instead of 1/3, if I multiply by 1/2, nothing will change, no? Again, they will remain constant. So, I will write 1/2 m1 n1 v rms square is equals to 1 by 2 m2 n2 vrms 2 square. Clear nama? This is equals to 1 by 2 m3 n3 vrms 3 square. I can write like this. Okay. But previously what we have studied, if velocity of each gas molecule is temperature, if they are same, then kinetic energies, they remain same number. And what are the kinetic energies here? Kinetic energy half m vrms square only, no? So half m vrms square of first gas, half m vrms square of second gas, half m vrms square of third gas should be constant, because temperatures are constant. Okay. So just you cancel them. Clear? Now what I am left with? I am left with n1 is equal to n2 is equal to n3. It means number of molecules which are present in first gas is equal to number of molecules which are present in second gas, and that is again equal to number of molecules present in third sample of the gas. Understood, Nama? Have you understood why I have cancelled half m vrms square? Temperatures are same, no? So kinetic energy of every gas is a constant. Okay? But individual masses may be different. RMS velocity also may be different, but kinetic energies remain same. This is a very important point, ma. Are you able to understand? In each gas, mass may be different, mass of each gas molecule. Velocity also may be different, but kinetic energies will be same if temperatures are same. So therefore, I have cancelled all the kinetic energies. So therefore, what I am left with? I am left with N1 is equal to N2 is equal to N3. And this is exactly what is called as Avogadro's law. Understood, no? If temperatures, velocities and pressures, if they are equal, the number of molecules of each gas always remains a constant. That's it. Clear, no? Okay, ma? So let us see the next topic, which is called as Dalton's law of pressures, ma? Dalton's law of partial pressures. Okay, see, ma? So see, ma, for example, if I take one container, listen, this is a container in which there are 2, 3, 4, 5, any number of gases. Let us take 3 gases are present. So oxygen gas is there, hydrogen gas is there, as well as nitrogen. 3 gases are present. Are you able to understand, ma? So here, the point which we have to understand very carefully is that every gas is occupying total volume of the gas. It is not that oxygen is occupying only V by 3, okay, ma? Hydrogen is occupying only this much part of volume. Nitrogen is occupying remaining volume. Gases doesn't behave like this, okay? So gases will occupy total volume, what is available to them. Okay, ma? If total volume of this container is V, oxygen will occupy how much volume? V. Total V. Nitrogen also will occupy total V. Similarly, hydrogen also will occupy total volume of the gas. Okay. Similarly, their temperatures also will be same only. If one gas is at a temperature of 30 degrees Celsius, remaining 2 gases also will be at same temperature. So this is one point which you should understand. Okay, ma? So first note point is every gas will occupy total volume and all the gases will be at the same temperature. Clear, ma? Now if I see that, if total pressure exerted on the walls of this container is P, okay, ma? Total pressure exerted by walls of the container is P. Then this total pressure, it will be the sum of individual pressures, P1 plus P2 plus P3. This is understandable only, no, ma? Clear, no? What is P1? P1 is the pressure exerted by oxygen. P2 is the pressure exerted by hydrogen. P3 is the pressure exerted by nitrogen gas. And sum of all the pressures is nothing but total pressure exerted on the walls of the container. Clear, no? So therefore, if I want to write this one according to ideal gas equation, how I can write sigma? So ideal gas equation, we know that pressure is equals to nRT, no, ma? PV is equal to nRT. What is meant by P? P is the total pressure. Total pressure can be written as P1 plus P2 plus P3. Partial pressures exerted by each gas. P is called total pressure, ma. P1, P2, P3, they are called partial pressures. Partial pressures means pressure exerted by each gas. Clear, no? And total volume remains the same, no? Because in the same volume, all the gases are present. And N also I can write N1 plus N2 plus N3. I can write like this also, no? Clear, no, ma? What is N1, N2, N3? Total number of moles of the gas. N1 is the number of moles of first gas. N2 is the number of moles of second gas, like this. So multiplied by R into T. This is what I can write. So I can change this ideal gas equation according to number of gases also. Is it clear, ma? Let us see one more point which we can still manipulate here. See, ma, Already we studied that V comma T, they are constant, no? Every gas will occupy same volume, so volume remains a constant. Every gas is at same temperature. Temperature also is a constant. What about R? R is already a constant. Clear, no? R is also a constant. So therefore, can I say that total pressure, clear, number, is directly proportional to total number of moles. Can I write like this? Are you able to understand, number? So total pressure exerted in the gas, exerted by the gas, is directly proportional to total number of moles of the gas also. Okay? It means as number of moles of gas increases, pressure also increases at same temperature. Number of moles means number of gas molecules only, no? If number of gas molecules increases, they go and strike the container at a number of places. Total force increases, area remains same. So pressure automatically increases. Are you able to understand? What is the reason for pressure? Collision of gas molecules, no? More number of gas molecules are there, pressure also will be greater. So therefore I can say that, clear, number, pressure is directly proportional to number of moles of a gas, or you can say P by N remains a constant. Can I say like this? By using the same concept, we have done many problems in chemistry. Do you remember? P by N remains a constant. P is the pressure exerted by a particular gas, N is the number of moles of the same gas. Okay? So what is the pressure ratio? Same is the number of moles ratio also. That is same equation. How I can write? Okay, ma? So see. So from same Dalton's law of partial pressure, see how many equations we can derive. So P1 by N1 is equal to P2 by N2 is equal to P3 divided by N3, and all of them, they should be constant. So if I take these two equations, I can write P1 by P2 is equal to N1 by N2. I can write like this also. Can I write? So this P2 I am taking here, N1 I am taking to the other side. So P1 by P2 is equal to N1 by N2. What is meant by P1 by P2? Ratio of pressures. What is N1 by A2? N1 by N2, number of moles of a gas. So pressure ratio is always equal to moles ratio. Understood, Dama? So write that statement. So this derivation we have not done in chemistry, no? Here we are doing the derivation because here it is very important. Therefore what we write? Therefore we write, clear, Nama? So pressure ratio is always equal to number of moles ratio. Okay, ma? What is the pressure of the gas of two different gases? Same is the moles ratio also. Okay? Or same statement you can write like this also. How you can write? See, ma. I can write partial pressure of any gas divided by total pressure. This is equals to number of moles of any gas divided by total number of moles. I can write like this also. Are you able to understand, ma? Now these are the pressures when compared to another gas. Now I am comparing the pressure with total pressure. Similarly, number of moles also should be total only. So I can write like this also. Are you able to understand? Same equation again, how I can write now, see. So P1 is equals to total pressure multiplied by mole fraction. I can write like this also, no? Clear now? This is one more equation. What is N1 by N total, ma? Mole fraction. What is meant by mole fraction? You should have studied in chemistry, no? Number of moles of a gas compared to total number of moles of a gas is called mole fraction. Okay? And what is P total? Total pressure of a gas. Okay? So how can you read this equation in statement form, ma? Come on. Partial pressure of any gas is equal to total pressure in the container multiplied by mole fraction of that particular gas. Clear? That's it. Very simple. So therefore, in statement form, how I can write? Let us see. Come on, in the form of statement, I can write partial pressure of a gas. Okay, ma? This is equal to total pressure, or first of all I will write mole fraction multiplied by total pressure. So this is also a very important equation in solving the problems. Okay. Partial pressure exerted by any gas, that is equal to mole fraction of that gas, mole fraction of the gas multiplied by total pressure of the gas. Clear? So from which concept we have derived this one? We have derived this one from Dalton's law of partial pressures. Again by using ideal gas equation. PV is equal to N naught. Clear, ma? That's it. See, ma. Another form of ideal gas equation. What is one form of ideal gas equation, ma? PV is equals to nRT. This is one equation of ideal gas equation, no? Now see, ma, here N is number of moles of a gas. Clear? Number of moles of a gas, I can also write total mass of the gas divided by molecular mass, or I can write total number of molecules divided by Avogadro number. I can write like this also. In terms of volume also I can write. Okay. So therefore substitute here. So PV is equals to N by NA multiplied by RT. Okay, ma? So same equation how I can write? I can write PV is equals to N multiplied by R by NA multiplied by T, where this R by NA is called as K, Boltzmann constant. Already we have studied previously, no, ma? K is called what? K is called as Boltzmann constant. Okay. So therefore I can write PV is equals to NKT, capital N multiplied by K into T. So this is one more form of ideal gas equation. Understood, no? Where P is called pressure, V is called volume, and N is called as number of molecules. It is not number of moles, no. Small n indicates number of moles. Okay, ma? What is capital N? Capital N is number of molecules or atoms present in the gas. Okay, ma? So in terms of moles, this equation. In terms of molecules, this is the equation. So this is second form of writing ideal gas equation. Understood, no, ma? So we will remember up to here. So problems and next concept we will discuss in the next class. Okay, ma? So let us see this question, ma? So there is a cubical cylinder, ma, in the shape of a cube, okay, in which 0.5 grams of hydrogen gas is present, and what is the length of each side of this cube? 3 centimeter, okay. So at NTP, normal temperature and pressure, so the gas in the chamber is compressed, keeping the temperature constant until a final pressure of 100 atmospheres is reached. Clear? So is the concept of ideal gas still it is valid or not? That is the question which he is asking. It means first of all you should know what are the properties of ideal gases. Many times we discuss the properties of ideal gases, no? In chemistry also one time I have given you the properties. I think in starting of KTG also I have given the properties of ideal gases, no? So these properties of ideal gases, are they still valid or not? That I want to find out. First of all let us see what is the diagram we can draw, ma? So consider this is a box, cubical box, clear, ma? A piston is present here, okay, and by using this piston we are compressing this gas, we are pushing this gas, so that piston moves downwards. Are you able to understand? And we are doing the process very slowly, ma? Then only temperature remains a constant, okay. So first point is that process is very slow. Very slowly we are compressing the gas. Why we are pressing very slowly? That we will study in thermodynamics. Are you able to understand? We will press this piston very, very slowly. Then only temperature remains a constant. Are you able to understand? What are the initial conditions which are given? NTP, normal temperature and pressure. It means temperature of the gas is remaining to be 20 degrees Celsius, and pressure, initial pressure P1 was how much? Initial pressure was 1 atmosphere of pressure, 1.05 into 1.01 into 10 power 5 Newton per meter square is also called as 1 atmosphere. Are you able to understand, ma? So NTP means temperature is 20, pressure is 1 atmospheric pressure. This is the condition. Now if I start compressing this piston, and when temperature is remaining constant, what happens to volume? Volume reduces. No? If I start compressing the gas, Jayanti, Vinali. Listen very carefully. Clear, ma? Okay? So if I start compressing this piston or pushing the piston downwards, volume reduces. No? But what about temperature? Temperature is a constant. So if volume reduces and temperature remains constant, what happens to pressure? What happens to pressure? How can you say pressure increases? So when temperature is a constant, okay, ma? Then how pressure and volume they are related? They are related like this. No, pressure is inversely proportional to volume. What is this law called as? Boyle's law. So why don't you apply Boyle's law? If volume is reducing, what happens to pressure? Pressure continuously increases. This is what happens, no? Because pressure into volume should always remain a constant. So volume is continuously decreasing, pressure is continuously increasing. So pressure increases up to which value? Pressure increases up to a pressure of 100 atmosphere. Initial pressure was only 1 atmosphere. So this is the given condition. Are you able to understand, ma? Now we have to prove whether ideal gas properties, if they are satisfied or not. So what is meant by ideal gas properties, ma? Name some properties of ideal gases. We consider all molecules to be perfect spheres. This is one property. Clear, no, ma? We consider there are no forces of attraction or repulsion between the molecules. We consider all the collisions are elastic collisions. Still, we consider size of the gas molecules is very, very, very less when compared to the size of the container. This is what we understand. No? Are you able to understand? No? We consider size of the gas molecules is very less. Our combined volume of gas molecules is very less when compared to total size of the container. But now we are compressing this container to a very, very small volume. No, ma? So now we will check what is the volume of gas molecules and what is the volume of container. Are you able to understand? Then we will try to see whether this gas laws, if they are satisfied or not. Ideal gas properties, if they are satisfied or not. Are you able to understand? So first of all, we will calculate volume of gas molecules. Okay, ma? Volume of only gas molecules if I take. Okay? See, ma. So how many moles of hydrogen is taken, ma? 0.5 grams of hydrogen gas is taken. Okay? Then can you say total how many moles of hydrogen gas is present? Number of moles, how can I calculate? So number of moles can be calculated by total mass divided by molecular mass. This is how we calculate number of moles, no? Are you able to understand? So therefore, what is the given mass? Given mass is 0.5 grams. What is the molecular mass of hydrogen? 2. So therefore, 1 by 2 by 1 by 2 is 1 by 4 mole. So how many moles of oxygen gas is present? 1 by 4 mole of hydrogen gas is present. Okay. So therefore, totally how many molecules of hydrogen are present? Number of molecules are how many? 1 by 4 into Avogadro number. That's all, no? Are you able to understand, ma? So 1 by 4 multiplied by Avogadro number will give the number of molecules of hydrogen which are present. Are you able to understand? So what is Avogadro number? 1.4 into 6.023 into 10 power 23 molecules of hydrogen are present. Okay. So these many molecules of hydrogen is present in this gas container. Are you able to understand? Okay. So therefore, what is the combined volume? Combined volume of hydrogen gas molecules is how much, ma? Can you say? Okay. Combined volume is how much? See, ma. So what is the size of hydrogen he gave? Size means the diameter is given as 1 angstrom. Are you able to understand, ma? So I think he gave diameter or radius. Let us see, ma. He gave radius, ma. He didn't give volume. So hydrogen molecule radius is how much? It is equal to 1 angstrom. Are you able to understand? So can you say, how can I calculate the volume of total hydrogen gas molecules, ma? Number of molecules I have. Okay. Their combined volume, how can I calculate? First of all, hydrogen gas is what shape of molecule? Cubical shape or spherical shape? What kind of shape? Spherical shape only, no? Volume of a sphere? 4 by 3 pi r cube. So 4 by 3 pi r cube. This is the volume of a single molecule. How many molecules are there? This many molecules are there. So multiplied by 1.1 by 4 multiplied by 6.023 into 10 power 23. So this is the combined volume of hydrogen gas. Are you able to understand, ma? So if I do this calculation, and 1 angstrom is how much, ma? 1 angstrom is nothing but 1 into 10 power minus 3 minus 10 meters. Oh, so if you substitute all these values, let us see what is the volume I will get. Okay, ma? So it is 6 into 10 power minus 7 meters. So 6 into 10 power minus 7 meter cube. So this is the volume of combined volume of hydrogen gas molecules. Are you able to understand? So what is this volume? This is just the volume of all the hydrogen molecules. Now this volume I have to compare with final volume of cylinder. That one how can I calculate? Volume of cylinder how can I calculate, ma? That's it. So next I am calculating volume of cylinder. Final volume of cylinder. Initial volume already I know no, ma, because he said it is having a side of 3 centimeter, no? So its initial volume is 3 into 3 into 3. Volume formula A cube only, no, for a cube. Final volume how can I calculate? So temperature is a constant, no, ma? Because temperature is a constant, can I write PV should be a constant? The product of pressure into volume should be constant, Boyle's law. Okay. Therefore, I can also write P1 V1 is equals to P2 V2. So this is before compressing and this is after compressing. Okay. What is the initial pressure? Initial pressure is 1 atmosphere multiplied by initial volume is how much? 3. No need of writing here the multiplication factors, because both sides they will get cancelled. No, directly I will write a 3. So 3 cube. Are you able to understand? Final pressure is how much? Final pressure is 100 atmosphere. And final volume is how much? That I don't. Clear? After compressing. So final volume is how much? V2 is equals to 9 divided by 100 meter cube. Are you able to understand? What 20? Sorry. 3 3s are 9, 9 3s are 27. So 27 divided by 100. So we must write conversion units of volume, because on both sides they will not get cancelled, no? So it is given as 3 centimeter, no, 1 centimeter is equal to how much? 10 power minus 2 meters. So I will write 3 into 10 power minus 2 whole cube. That is the volume of the initial volume of the container. So therefore final volume is how much? Final volume V2 is equals to, so 27 into 10 power minus 6 divided by 100. Are you able to understand, ma? So therefore if I do this value, so how much it will be? So 27 into 10 power minus 8 meter cube. If I want to compare these two, then I will do one thing. So I will write, so 2.7 into 10 power minus 7 meter cube. Are you able to understand, ma? So what is this V2? This is the final volume of the container. That's it, no? What is this volume? This is the volume of hydrogen gas molecules. Okay, ma? Just if you take the combined volume of hydrogen gas molecules, this much will be the volume. If you take the final volume of the container, this is the final volume of the container. Now when you look at both of them, what do you understand? Which volume is greater? Which volume is greater? Volume of gas molecules is very large, no? When compared to volume of the container. This is 6 into 10 power minus 7. This is just 2.7 into 10 power minus 7. Are you able to understand, ma? So, but according to ideal gas, what is the condition we have studied? Volume of the gas molecule should be negligible, very less when compared to volume of the container. But this is not satisfied, no? Are you able to understand, ma? So here gas is deviating from ideal gas behavior. It is not following the properties of ideal gas. Are you able to understand? So that is what we have to prove. So write down. So therefore what we write? Therefore we write that, okay, ma? So as volume of gas molecules is greater than volume of container. Okay, ma? So we say that gas deviates from ideal gas behavior. Okay, ma? It is not following the properties of ideal gas. Have you understood, ma, how we have done this calculation? So, Sima, this is the next question. So, volume of the vessel is given 2 into 10 power minus 2 meter cube. So, it contains a mixture of hydrogen and helium. Both gases are present, mixture of gases. So, what is the initial temperature? 47, and this much of pressure is present. Then mass of the mixture is also given, ma. So, 10 power minus 2 kg. Then calculate the masses of hydrogen and helium in the given mixture. That is separately what is the mass of hydrogen and what is the mass of helium that I want to calculate. Are you able to understand? So let us see, first of all, how we can proceed in this problem. Sima. So this is a container in which two gases are present. What are the two gases which are present? Clear, ma? So one is hydrogen gas and the second one is helium gas. So two gases are present. Are you able to understand? So, what is their combined mass, ma? So mass of helium plus mass of hydrogen is how much? It is 10 power minus 2 kg. And their combined pressures is also given, 4.15 into 10 power 5. So when you look at this data, what do you understand? What do you understand? We can write ideal gas equation, no, ma? So PV is equals to nRT. This equation we have, no? Okay. So in this container, there are two gases. Helium gas is also present. Hydrogen gas is also present. Okay. So pressure is because of partial pressures of both gases, no? Can I write like this? Instead of P, I can write a P1 plus P2, no? Yesterday only we discussed Dalton's law of partial pressures, no? So total pressure exerted will be the sum of individual pressures exerted by the gases. Okay. And volume is how much? Volume is V only. Because every gas will occupy total volume, no? So P1 plus P2 into V is equals to number of moles. Number of moles, I can write N1 plus N2. N1 is the number of moles of helium, N2 is the number of moles of hydrogen. Multiplied by R into T. This is what I can write. I can write like this, no? So therefore, what is the combined pressure? Combined pressure is already given, no, how much? 4.15 into 10 power 5. Okay. Multiplied by volume is also given. What is the combined volume, ma? So it is also given as 2 into 10 power minus 2. Okay. So this is equals to number of moles of hydrogen and helium, I don't know. Are you able to understand, ma? So number of moles can be written as mass of helium divided by molecular mass of helium. This is the number of moles of helium gas. Similarly for hydrogen also, how can I write? Total mass of hydrogen divided by molecular mass of hydrogen multiplied by R into T. I can write like this, no? Are you able to understand, ma? So molecular mass of helium, we know. Similarly molecular mass of hydrogen also, we know. So if you substitute all these values, R value also I know, temperature also I know, 47. If I substitute all these values, I will get one more equation for mass of hydrogen and mass of helium, no? So here already there is one equation, first equation. So solve both the equations, you will get the answer. That's it. Are you able to understand, ma? So this is the first equation which is based on masses of hydrogen and masses of helium. So from here I will get another equation, no? For example, mass of hydrogen, molecular mass of helium is how much? 4 AMU. That's all, no, ma? Molecular mass of single molecule of helium is how much? 4 AMU. But here every value is given in SI system, no? What is pressure? Pressure is given in Newton per meter, SI system. Volume is given in meter cube, again SI system. So AMUs also I have to write in SI system. How can I write it in SI system? 4 into 1 AMU is how many kgs? 1.66 into 10 power minus 27 kg. So this is 1 AMU. Already we discussed, no? 1 AMU is equal to 1.66 into 10 power minus 27. So this is the mass of molecular mass of helium. Similarly, what is the molecular mass of hydrogen? Okay, ma? Hydrogen in terms of AMU, 2 AMU and 1. So if you substitute all these values, then this is the relation which you should get. Clear? So 2 times of mass of helium plus mass of hydrogen is equal to 12.48 into 10 power minus 3 kg. Clear? So this is my second equation. So already we have the first equation, no ma? So solve both these equations. Then you will get individually the mass of helium and mass of hydrogen. And these calculations I am not doing. You should do these calculations. So mass of helium gas present in this container and mass of hydrogen gas present in this container. Okay, ma? So mass of hydrogen. Helium is M2, na? 2M1 plus M2. This is hydrogen, ma? And this is helium. Correct it? Similarly, this is hydrogen and this is helium. Okay? So, if you do these calculations, answers I am writing, na? You check your answers. M1 ante hydrogen. Mass of hydrogen is 2.5 into 10 power minus 3 kg. Okay. And mass of helium is 7.5 into 10 power minus 3 kg. So those are the answers which you should get. Okay.